Hello, everyone. Thank you for joining AWS Builders Online and welcome to this session. This session is going to be really exciting as we're going to discuss about how we can run container-based applications with AWS. And not only running them, but also how to implement a few of best practices with AWS services. My name is Doni Prakoso. I'm a senior developer advocate covering for ASEAN. After this session, you will have a good understanding on the overall essential container services on AWS. And you will be able to identify which service that you can use for your development workflow. You will also understand how to use AWS Copilot to deploy and operate your applications into Amazon ECS and AWS Fargate, and some of the most common cases such as deployment, scaling, integration, as well as implementing CI/CD. So many fun stuff today, and let's get started. In this session, we have lots of things to share with you, especially for the demos. We're going to build an API to convert Markdown input to HTML output, and we can test it out using curl command. A sample demo is like what you see on the screen, and we're going to deploy the application using Amazon ECS and AWS Fargate. But we will not stop there. We're also going to integrate the application with DynamoDB to show you how to integrate your apps with other AWS services. And lastly, modern application is not complete with CI/CD, and we're going to walk through on how that you can build a simple but powerful release pipeline with AWS services and using a single tool, AWS Copilot. So let's first talk about containers and how we can do development with Docker. When we build application, in order to have our app runs properly, there are a couple of parts that we need to integrate. As you begin working with applications, you start to realize that applications are not just code. They are built on other components that we call as dependencies. These dependencies include the runtime that executes the application code. And say that you're running the Node.js runtime, you may also need to pull in JavaScript packages via the NPM. And one of the key benefits of containers is that they're able to convert applications into a single deployable artifact. They take the application code along with all of those dependencies like runtime, libraries, and configurations and package them together into something called as container image. And once that you have the container image, you can consistently and easily run the application anywhere as long as there's a container runtime. So let's jump into the demo where I will show you how to package your application with containers and run the application. In this demo, I'd like to show you on how we could package our application with Docker and how to run the containers application. Just a quick overview on what kind of app that we're going to deploy today. The application that we're going to deploy is a simple application to return HTML based on the Markdown text that we pass as input. So the application will convert the Markdown text into HTML using HTTP post method, and we can use the output. This is the structure of the application. We have the source code for this application. The app itself is written on Python and running on Flask framework. I'll cover more details on the next demo. Once that you have your application ready, the next thing that you need to do is to structure the Docker file. A Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. And what you see now is the Docker file of the application. Let me briefly share with you the Docker file instructions to successfully build the container image for this application. The from instruction initializes a new build stage and sets the base image to Python 3.8 as the application is running on Python. The copy instruction copies the app.py and requirements.txt as those are the files required in the next instruction. The run instruction will execute pip install, which will install all libraries required to run the application. Then the expose instruction informs Docker that the container listens on the port 9090 at runtime. And lastly, the cmd is the command to execute the container. In this case, I'm using the unicorn to run the application. Once that we have the Docker file ready, the next thing that we need to do is to build the image. We can do this by running docker build. This will create the container image with the tag. And if we list down the images, we will see it's created. And if we run docker run and exposing the port, it will run the application. And if we test by passing the input, it returns the HTML response. So it works, although it's still running only on the local host. Okay, so running a single container is easy, like what we have just seen in the previous demo. But in reality, we often need to deploy more than one container. And things could become more complicated, as in practice, we also need to deploy to several different environments, like UAT, staging, or production. And not only the environments, depending on the workload of your application, you probably need to deploy to tens, hundreds, or thousands container instances. So what is the solution for these challenges? You need a tool that can automate your container lifecycle on top of managing your infrastructure. And this is the perfect transition for us to take you to the next segment, and that is AWS services that you can use to do development and deploying at scale for container application. The essential service to run containers on AWS is Amazon Elastic Container Service, or Amazon ECS. And what Amazon ECS is really excel at is the simplicity it provides. With Amazon ECS, it reduces the time it takes for you to build, deploy, or even migrate your containerized application. And it also comes with AWS opinionated solution for running containers at scale. And this also translates to various best practices of running containers already baked inside the service. As Amazon ECS is the container orchestrator, they still need computing instances to host our application. And I'd like to share with you about AWS Fargate, a serverless container and fully managed data plane that you can use to run your application. And why Fargate matters to you? Simply because Fargate runs in serverless mode, so you can focus building on your product and not the infrastructure. Fargate can also provide a significant operational saving. Why? Because with Fargate, it frees you from having to manage any of the underlying infrastructure, and it also comes with improved security. And when you are working with containers, you also need to have a container registry. And this is where you will need Amazon Elastic Container Registry, or Amazon ECR. Amazon ECR is high performance, scalable, and highly available container registry with deep integration in AWS ecosystem, making it the best choice for you to use it as a repository to centralize your container images. Now, in this session, we like to emphasize on how you can get started easily with your container application. So we're going to focus on simplicity, but still giving you the rich features and powerful ability of Amazon ECS. And we're going to integrate with AWS Fargate, serverless containers, so you can have more time to build your apps and not managing your infrastructure. And also, we're going to integrate with Amazon ECR so we can host our container image. And you're probably wondering, hey, there's so many services that I need to learn how to use it. How can I get started easily? And that's where AWS Copilot comes into the picture. AWS Copilot is a CLI tool that will greatly help you to get started with containers. AWS Copilot is the best tool for you to work with Amazon ECS, AWS Fargate, and Amazon ECR, as it abstracts away the complexities on using these services. Not only is the best tool for you to get started, but also give you the flexibility to extend your system. So in case that you're now starting with a simple application or you want to extend your architecture into microservices, AWS Copilot has it all for you. If you're just getting started, you probably have all of these questions. How do I deploy my application? How do I extend the system? How do I integrate with CI/CD? And the list goes on and on. And that is why AWS released AWS Copilot. AWS Copilot is a command line interface, or CLI, that you can interact in your terminal. AWS Copilot provides a simple declarative set of commands, including examples and guided experience built in to help you deploy your apps quickly. And one of the advantages of using Copilot is that all AWS best practices are embedded into this tool, so you can have scalable, reliable, and extensible applications with minimum efforts. Probably the first question you have in mind is, okay, so how do I deploy apps with AWS Copilot? With Copilot, you can easily deploy your apps by using two main commands, Copilot init and Copilot service deploy. And to show you how you can do this, let's jump to demo and see AWS Copilot in action. In the next demo, we're going to deploy the application that we used in the previous demo and deploy it into Amazon ECS and AWS Fargate. Just a quick overview on what kind of app that we're going to deploy today. The application that we are going to deploy is a simple application to return HTML based on the markdown text that we pass as input. So the application will convert the markdown text into HTML using HTTP post method. Although this is a simple architecture, but we are going to implement best practices as we're going to deploy into application load balancer with public IP address, which will be connected through AWS Fargate service that we configured properly inside the Amazon ECS cluster. Let's jump into the demo. In this demo, we'd like to show you the capabilities of AWS Copilot to deploy your application. This is the source code of the application. The application itself is written in Python and using Flask framework. For the same endpoint, which is root, I have defined different processes for get and post methods. For every request to get method is simply going to return OK. This endpoint with get method is mainly used for health check by ALB. The other method, which is post, is going to process the markdown text and return the HTML response. I also have a Docker file that's going to be used to deploy the application. This Docker file uses Python 3 as the base image and is going to install the requirements, running on port 9090 and run the application. At this stage, I already have a test environment probably configured by AWS Copilot. If you're wondering how to build environments with Copilot, I will show you in the next demo. But for now, we already have the test environment. Then all I need to do is to deploy the application by running command Copilot service deploy along with the service and the environment name. And once it's finished, we will get the endpoint. Cool. Now let's test it out. I'm going to test the endpoint using curl command. With this curl command, I'm sending a request with post method along with the input using a text as the variable name. The value of the text input is a text in markdown format. And we get the results. As you can see in this demo, Copilot makes it easy to deploy application into Amazon ECS and AWS Fargate. So in the previous demo, we learned how to deploy with Copilot. But hey, what about scaling? Obviously, we need to have this mechanism to run our apps at scale. Copilot has a built-in directives for you to define horizontal scaling on how many desired tasks should run for each service. With Copilot, you can define the range for application autoscaling target, use Fargate spot instances for cost-optimized containers, or scale based on CPU, memory, request per task, and service average response time. Let's jump into the next demo where we are going to show you how we can scale our application in different environments. In this demo, I'd like to show you how you can configure scaling for your application running in different environments. In this application, I have a service called Markdown running in two different environments, prod, which is short for production, and staging. If you're wondering how we can create multiple environments, we can do that by running Copilot env init, which will guide you to create another environment for your services. Alright, and what I like to do now is to configure the scaling for both environments based on CPU and memory usage, but define higher range for production, simply because prod environment has more requests compared to the staging. Right now, the Markdown service is currently running with only one task with the lowest vCPU and memory for both environments. So what I need to do now is to open the manifest file for Markdown service located in Copilot folder. If we scroll down here, we have the count property. It's worth to mention that you can configure application auto-scaling here, but it's going to be implemented to services running in all environments. What we want to do is to have different configuration for each environment. If we scroll down below, we'll find environment section. Here we can define properties that we like to have in different environment. And here we can also override properties defined above. So let's start with staging. For staging, we like to have minimum of 2 tasks and maximum of 5 tasks, with CPU usage percentage set to 75. You need to set these properties whenever you use the range properties for scaling. You can also use memory percentage, request and response times properties. And for production, I like to change the higher CPU and memory for prod environments. I'm going to set the CPU to 1 vCPU and 2 gigs of memory. And as for scaling, we'd like to have minimum of 10 and maximum of 20 tasks, and set the scaling for average CPU to 75%. So this means that for production, if the CPU utilization rises above 75%, then our task will be scaled out up to 20 tasks to help out with the increased load. Now, if the CPU utilization falls below 75% for a period of times, then a scale in will be initiated to decrease number of tasks in this service to free up the resources. Alright, we're done here. Now we're going to deploy the Markdown service for both environments, staging and prod. First, let's deploy it for staging. Alright, and now let's deploy it for production. Okay, it's done now. Now we can check if the configuration are properly implemented by checking with Copilot service show. This is the configuration for Markdown service in both environments. Here we see that the staging has 2 running tasks and same vCPU and memory. While for prod, we can see that we have 10 running tasks with 1 vCPU and 2 gigs of memory. This means Copilot successfully configured our auto-scaling policy, and our apps will scale based on this configuration. As you develop your applications, you will certainly add new features. And most of the times, new features also require integration with specific AWS services. So how can we do that? You can use Copilot Storage Init command to help you integrate with Amazon S3, Amazon Aurora, and Amazon DynamoDB. In the next demo, we will show you how we can add integration for our Markdown Service API with Amazon DynamoDB to log all the requests into a database. Copilot will also create necessary IAM role and inject environment variables for us, so all we need to do is to code the integration in our application. Wondering how all of this works? Let's jump into the next demo. Okay, so now we have our API app deployed, but it needs a database so we could log all the requests. Let me guide you for a quick walkthrough for the source code. This is the app.py file, the main file for the API application. I have added a new function which is called as save data. This function will save the request this application received into DynamoDB table. And if we go to the main function, you see that I have added a line to call the save data function. Our code already integrates nicely with DynamoDB, and what we need is the DynamoDB itself. So let's run Copilot Storage Init. Once we run this command, it will ask us a couple of questions, like storage type. In this case, we choose DynamoDB. Then the resource name. partition key, and others. Let's finish this process. Okay, so it's done creating the manifest. And you can also see the environment variable name for the DynamoDB table that we can use in our code to define the object for DynamoDB table name via the environment variable. So let's change the table name by using the value from environment variable. Okay, so now the application should connect to the DynamoDB properly. Next, manifest file. To find the manifest file, you can browse to the add-on folder. As mentioned, if you need to integrate your application with other AWS services, you can create AWS CloudFormation template in this folder. Let's take a look into the manifest file. This is how manifest file looks like. It's a CloudFormation template, and in this case, it defines Amazon DynamoDB for our application. If we scroll down to the end of the file, you see there are two outputs, and one of them is the IAM role. This is important, and hope you don't miss this part, because this IAM output will help Copilot to inject into your application so it has sufficient permission. Alright, at this stage we don't need to change anything, so let's deploy this DynamoDB integration. To deploy the application, I just need to run Copilot service deploy and add the service name. This will take a while, so let's wait until it's finished. Alright, seems the deployment is finished and we have all required resources, from DynamoDB to the IAM role attached to our application. Okay, so there's no issue, which is good. I want to check if the DynamoDB is created, so let's go to the console. This is my DynamoDB console. And if I filter by the name, I can see there's one DB is created. Now, if you run the API endpoint again, it now will log the data into DynamoDB. So let's go to the DynamoDB console to see if the last request is logged properly. Okay, so our application now integrates nicely with DynamoDB. And we can see the last request is in the database. And this is how you integrate your application with other AWS services using Copilot. In the previous demo, we have learned on how that we can use AWS Copilot to deploy and scale our application. Now, when it comes to modern application, one of the best practice is to implement CI/CD as early as you can. And CI/CD gives you benefit in the long run as it will increase your development velocity. And with Copilot, you can easily create another environment using Copilot Env init. And if you want to implement CI/CD for your applications in any environments, you can simply run Copilot pipeline init. So in the next demo, we're going to build a release pipeline. So whenever we push our changes into our Git repository, it will automatically build the image, push to the container image repository, and deploy to specific environments in Amazon ECS and AWS Fargate. It's not as hard as it seems. In fact, with Copilot, it's as simple and straightforward. Let's jump into the next demo to implement CI/CD with Copilot. In this demo, we're going to create a release pipeline for a single environment. We're going to use the demo that I used in the previous demo. Before we're going to create a release pipeline with AWS Copilot, I'd like to show you how to create an environment with AWS Copilot. To create an environment, you can use Copilot Env init command. Copilot Env init creates a new environment where your services will live. Copilot will guide you throughout the process and ask you a couple of questions, such as the environment name. In this case, I name it as test. And also the name profile to specify which AWS account and region I like to have our application to run in the environment. I will use my default profile for this demo and just let it finish the process. You can also use various flags provided by AWS Copilot to create environment. For example, You can also import existing resources like VPC and subnets to your preference. Now, as we have an environment for our apps called test, the next thing that we need to do is to deploy our application in test environment. To deploy our application, we can use Copilot Service deploy command. Now our application is deployed. Let's check the application by running Copilot Service show. Again, if you didn't specify the information with flags, it will guide you throughout the process. And this is something that I really like, as it's quite intuitive. Once that we have the environment built, we now can check the status of the environment using Copilot F show command. This command shows information about a particular environment. Some of the information includes the region and account of the environment, the production info if the environment contains production services, and also the services running in the environment. You will see that we have our application now running in test environment. Let's try to test it out. This is a simple application that's going to convert a markdown text to HTML. And if we do a simple curl command using post method along with the text variable, we're going to get the response in HTML. And this is good, since this means our application is running properly in test environment. Now let's try to create a release pipeline with AWS Copilot. To create a release pipeline, all we need to do is to have 3 commands. First, Copilot pipeline init. The second step is you need to commit and push all changes to our GitHub repository. And the third step is to update the pipeline configuration by running Copilot pipeline update command. Let's do them one by one. Let's run Copilot pipeline init. This command will not create your pipeline yet, but it will create manifest file that will be used to create your pipeline. You can find those manifest files inside the Copilot directory. There are 2 new files generated by Copilot. They are build spec and pipeline YAML configs. Let's go through each of them. Build spec file contains the instruction for building and publishing your service. For most cases, you can leave the build spec file as it is. But for some cases, you might want to run additional command, and you can add them into the build spec config. As for the pipeline file, this file contains instruction on how code pipeline needs to retrieve the source file, which environments you want the pipeline to deploy to. Now let's commit and push the files. Then we can instruct Copilot to integrate this pipeline with Copilot pipeline update, which will let Copilot to integrate with AWS code pipeline and AWS code build. In this stage, if you're using an external Git provider like GitHub, Copilot needs to create the connection and we need to update the pending connection as a way to approve it to make it available for use. So let's wait. We can also check the end result of our pipeline in the code pipeline console. This is the visual representation of our pipeline. You can see that we have 3 steps here: source, build, and deploy. So let's get back to our terminal and make some changes to our app to see if the pipeline works as expected. What I'm going to do now is to add environment variables into the application and retrieve it from the app. To do that, I need to open the service manifest file. Add the environment variable for test environment. I'm going to name it as running env, and with value, this app is running on test environment. And open our application file. And add the environment variables as the part of the response. And that's it. Now what I need to do next is to git push my changes. Now we can see the status of our pipeline with Copilot. And it's currently running. Let's wait until it finishes processing. And our app is deployed successfully. Let's test it out. To test this app, let's find the URL of the application by calling Copilot Service Show. And we also see that we have the environment variables from the test environment. Let's try to test it out. And yes, we can see that we got response from the app. We got the HTML response from the markdown input, and that means our application works. And that demo ends our session for today. If you want to explore more about AWS Copilot, here's a few additional resources for you. First, the AWS Copilot product page, which holds important information about the concepts that you can use to get started. And for you who want to dive deeper into more architectural patterns that you can build with AWS Copilot, you can go to copilot.rocks. In this site, you will find how to implement various architectural patterns, from how to implement service discovery to architecting pub/sub pattern, along with codes and step-by-step guidance. And we also have another resources for you for free. AWS Digital Training offers free digital on-demand courses which can help you learn skills and cloud services. Interested? You can register directly at aws.training. We really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey and let us know what you think. So that's all for today's session. Thank you for your time. Hopefully the content and demos presented in this session help you understand containers offering from AWS and how you can build, release, and deploy your applications easily with AWS Copilot, Amazon ECS, and AWS Fargate. And more importantly, for you to enjoy more and having fun building apps with AWS. Also, if you have any questions, feel free to contact me on Twitter or LinkedIn. Once again, thank you so much. I'm Donny Prokoso, and happy building.